Welcome back to Precalculus. We are starting our dive into conic sections. Now, conic sections are a group of shapes that are formed by intersecting planes with double right-angle cones. In the written notes, I've illustrated how that works, and there's plenty of videos on YouTube that show that relationship better than I ever could. In fact, I usually play some of them in class when we're meeting in a classroom. So rather than giving a foundation of where conic sections come from, what I want to say in this video to start us off is that conic sections is a time in math when we use the skills that we've learned in algebra to study objects that come from geometry, like circles, but also a few other different shapes. So we're going to start with the circle. So here is a circle. It has a center, it has the radius. These are things we're fairly familiar with already. The equation of the circle is x minus h squared plus y minus k squared equals r squared. Here's a good time to pause the video, write this down, and then hit play when you're ready to continue. The center is just the point h, comma, k. So we're looking inside these parentheses to find what this center is. If we just had x squared and y squared, then h and k would both be 0, so it would be centered at the origin. And then the radius is, of course, r. So, moment, I'm going to erase this. But one of the big goals that we have in conic sections is being able to translate between equations and their graphs, which is the geometric representation of this algebraic relationship. So we're going to take a moment to graph a circle. So I'm just randomly going to make up some numbers. Let's do x plus 4 squared plus y minus 3 squared equals, let's do 9. And so this is our equation, but we want to be able to graph it. So in order to graph it, we need to identify our center and our radius. The radius is perhaps the easiest part to identify. What is the square root of 9? Well, that's quite simply 3. So we know this circle has a radius of 3. We then need to identify what are the values of h and k. So h is going to be something to do with that plus 4. However, h is not positive 4. Because our formula says we have x minus h, the number that we plug in for h is actually negative 4. And over here, since we have the y minus part already, that means k is positive 3. We could go into a lengthy explanation about why this is the case. I'd rather you just think back to last semester when we were learning about transformations and translations in particular, since that is really where these ideas come from. So we're building upon things we've already known. So I'm going to draw out a graph. Hopefully, it'll be detailed enough in the video. And I'm going to begin by plotting the center. So it's negative 4, 1, 2, 3, negative 4. In the x direction, 1, 2, 3, going down. And that is our center. Now, the center is not technically a point on the circle, but it helps to plot this point because it allows us to more easily construct the circle. And what I mean by that is we know the radius of the circle is 3. So we can go 3 units in every direction to help give us some points to plot on our circle. So we can go 3 units up. This would be the point negative 4, comma 0. Go 3 points to the right. This is the point negative 1. So I've just realized that I have made a mistake. Perhaps you realized this already and you're just rolling your eyes at me that it took me so long. But what I'd like you to do, if you haven't yet realized the mistake that I made, pause the video, take a moment, look at what I've written down so far, and then hit play again. So the mistake that I made was I put the center at -4, -3, but it should really be -4, +3. So I actually need to go up 3 points here. So this is the center. So I can just kind of get rid of those 2 points. I can keep this point that I already drew in the same place because 3 points down from 3 does put us in the same place. But then 3 points to the right would be -1, or excuse me, -1, +3. And 3 points up would be -4, +6. And 3 points to the left would be -7, +3, yes. So I now have 4 points along the circle. The only thing left to do is, as neatly as we can, actually construct that circle. And there we go. We have our circle. We have gone from the equation to the graph. Now you might be wondering, well, how would I go in the other direction? And it's a fairly straightforward process. I have an example in the notes, but to just talk through the steps, I'd first want to identify how far across is the circle and how far up and down. Should be the same length. If it's not a circle. But what that will allow me to do is identify the diameter, which is 2 times the radius, and then just identifying where the center is, which is usually very reasonable to just do visually. We're able to identify those values for h and k and then plug them back into the formula. So we're really just translating between different representations of a relationship. The algebraic relationship is written as an equation. The graphical relationship shows the shape of the circle itself. So this was a quick introduction into circles. We're going to look at ellipses and hyperbolas over the next few videos. It's still to be determined as I record this if we'll have time to cover parabolas from the approach of conic sections. We've previously studied parabolas as polynomial functions, but there's some new ways of looking at them that are more geometric. But given the fact that we've transitioned to online learning for the remainder of the school year, it's not clear if we'll get that far. Fingers crossed, because I think it can be pretty fun. But at least, at minimum, we will have circles through hyperbolas.